Okay, picture this. You've got this amazing vision, right? A stunning 4K display in a really big space. Could be a conference room, maybe a church needing multiple screens, or, your ultimate dream home theater. You want that perfect 4K video, crystal clear, pristine audio, absolutely zero lag. The picture needs to be incredibly sharp. But here's the snag. You need that signal to travel quite a distance, way further than a normal HDMI cable can really handle without, well, falling apart. That's where you get signal degradation, fuzziness, maybe dropouts. It's just frustrating. So today we're doing a deep dive into fixing exactly that problem. We're exploring how to extend high-quality HDMI signals. And we're focusing on one specific bit of tech, the WolfPack 4K 60Hz HDMI transmitter over HDBaseT. This isn't just about, finding a longer cable. It's really about understanding the clever engineering that gets you uncompromising audio and video over surprisingly long distances. Now, our info for this deep dive, it comes straight from the source: product details, specs, technical insights on this specific WolfPack transmitter.
We're going to pull out the key bits to help you understand, first, what HDBaseT actually is, then how this transmitter works, and really what it can do for your high-def setup. So let's unpack this. We're talking crystal clear 4K video, much further than standard HDMI allows. Sounds tricky, but it's all engineering.
Yeah, and what's really interesting here is how HDBaseT just steps in. It's such a robust solution to what is honestly a very common challenge for installers, integrators, even home enthusiasts. It's not just a simple extender box. It's more like a foundational technology. It allows for future-proof, high-performance multimedia transmission over these long runs. We'll definitely get into how it works, but maybe more importantly, why it's such a game changer for keeping that signal perfect where it absolutely needs to be.
Okay, so let's start right at the beginning then. The problem itself. Anyone who's tried running a really long HDMI cable probably knows this pain. What exactly goes wrong? Why can't we just keep making them longer?
Right. And that's precisely why HDBaseT was developed. Your standard HDMI cables, they're designed for shorter distances, relatively speaking. As you increase that length, the electrical signal, the thing carrying your picture and sound, it starts to weaken. It loses integrity. And that shows up as, well, signal degradation. You might see sparkles on the screen, weird artifacts, maybe the resolution drops, or you just get a black screen, complete dropout. Plus, those really long, high-quality HDMI cables, they get super bulky, they're not flexible at all, and honestly, they get pretty expensive. They're just not practical for, say, professional installs or big setups where you might need to run cable hundreds of feet through walls, conduits, that kind of thing.
Yeah, that makes sense. The signal just can't keep up over that distance. So for someone who's only ever dealt with standard HDMI, is HDBaseT like a totally different animal to handle? Or does it slot into existing setups fairly easily?
That's a great point, because that's really where HDBaseT excels. It's a technology engineered specifically for uncompressed, lossless, and zero-latency transmission of that HDMI signal. And those aren't just buzzwords, right? They translate directly into a flawless user experience. Think about like a live surgical feed. Even a tiny delay or a single messed-up pixel could be critical. Or a huge concert. Video and audio have to be perfectly in sync, no compromises. HDBaseT gives you that absolute assurance. It removes that fear of the signal just breaking down over distance. Every single pixel, every bit of audio arrives exactly as it was sent. Identical quality at both ends.
Wow. No compression, no loss, zero latency. That really does sound like a game changer. So digging into the how a bit, what kind of wiring does it actually use to do this? To avoid the bulk and cost of those massive HDMI cables?
And this is a huge part of its appeal. It works over a single Cat6 or SHPO-up cable, UTP or SDP. So yeah, we're talking about standard Ethernet cable. The same stuff you likely use for your internet connection. It's much easier to pull through walls, it's more flexible, and often that kind of wiring is already in buildings. That makes installation way simpler and more cost-effective than special proprietary cables. That versatility is just a massive plus. And it's designed to be part of an ecosystem. This transmitter, for instance, connects seamlessly with other HDBaseT gear, receivers, matrix switchers. It lets you build out a flexible, scalable system.
That's brilliant. So it's basically taking the HDMI signal, packaging it smartly, and sending it over regular network cable. Are there other ways to distribute HD signals, and what makes HDBaseT stand out from those?
Well, what really distinguishes HDBaseT compared to some other HD distribution methods is how comprehensive it is. Some solutions might use their own special cables, or maybe they only focus on video. HDBaseT leverages that existing common Ethernet infrastructure. And not just for the video and audio, but also for control signals like RS-232, even standard Ethernet pass-through, and power over cable post-C. It's definitely optimized for video, giving you that full uncompressed signal, but it does much more than just extend video. It can be a true single cable solution for a whole bunch of AV and control needs.
Okay, that makes perfect sense. Now let's talk performance. The numbers that really matter when you're planning an install. Distance and resolution, they're key.
Right.
What can this specific WolfPack transmitter actually achieve? What are the specs?
Right, for those critical 4K resolutions, this transmitter is very capable. It handles full 4K at 60 Hz with 4.4.4 chroma subsampling. That's your top tier, full bandwidth 4K signal. And it can send that up to 70 meters. That's about 220 feet. Assuming you're using good quality K6, KED6A, or K7 cable, of course, that's a really significant distance for uncompressed 4K.
220 feet for full 4K 60. That is impressive. What about, say, 1080p? Or maybe a slightly lower 4K frame rate? Does the distance change?
Yeah, it does. If you're setting 1080p, you can push that even further. Up to 100 meters, which is roughly 330 feet, again, using good CC6 or CT7. And even 4K at 30 Hz, still with that 4.4.4 color that also goes up to the 220-foot mark. So you've got flexibility depending on the source signal.
Yes.
It naturally supports all the common resolutions too, 720p, 1080i, Full HD, UHD, and yes, even 3D content at 4K 60 Hz. In terms of the sheer data rate, it supports up to 18 gigabits per second bandwidth, which is crucial for handling those high-res, high-frame rate signals without cutting corners.
Okay, so the visuals are clearly top-notch. But, for anyone building a serious system, great picture is only half the battle. What about the audio? Does it keep up? Same uncompromised quality?
Absolutely. Yeah, the commitment to quality definitely extends to the audio side. This transmitter doesn't skimp on sound. It fully supports high-fidelity audio formats like 7.1 DTS Master HD and Dolby True HD. So you're ensuring that your sound experience is just as immersive and just as pristine as the video. You really don't sacrifice anything on the audio, even over those long distances.
And looking beyond just the signal itself, modern AV setups, they need to integrate. They need control. What about things like compliance with standards? Features that let devices talk to each other?
That's vital, yeah. For a smooth user experience, absolutely. This unit is fully compliant with HDCP 2.2 and HDMI 2.0. Those are non-negotiable now for playing protected content, streaming services, Blu-rays, modern game consoles. It also supports CEC consumer electronic control. That allows devices to sort of handshake, like your TV turning on your Blu-ray player automatically when you switch inputs. Simple, but useful. And then for more pro setups, it includes RS-232 support. That's for third-party control systems, plus all the essential background stuff like DDC-to-B for display communication, 36-bit deep color, X.V color for richer palettes, and full 3D support. It's pretty comprehensive on the connectivity and control front.
Right, so we've got picture, sound, control, compliance. Checks all the boxes. But for many of those demanding uses we mentioned, live events, big presentations, there's one more factor. It often gets missed, but it's where HDBaseT seems to really shine. Speed. Like almost instant. This fact genuinely surprised me. We're talking virtually no delay, almost nothing.
That's exactly right. And it's arguably one of HDBaseT's biggest strengths, especially in live situations. The latency is incredibly low. We're talking less than 7 microseconds. That's 7 millionths of a second. Over 220 feet of cable. If the run is shorter, say 100 feet, it drops to an amazing 3 microseconds. 3 millionths of a second. To put that in perspective, think about that church or auditorium again. It means the speaker's lips on the screen are always perfectly synced with their voice coming through the sound system. Wow. Even on displays hundreds of feet away, it's truly imperceptible to humans. Absolutely critical for live events, presentations, anywhere. Timing is everything.
That's just incredible. It completely solves that awful lip sync problem you sometimes see over long runs. Okay, switching gears just a little. One key thing about this specific WolfPack product, it's a transmitter only. What does that mean practically for someone buying it? How does it fit into the whole picture?
Yeah, that's an important point to make clear. Being a transmitter only means, well, it needs an HDBaseT receiving device at the other end. That completes the link. So that could be something like one of WolfPack's HDBase modular HDMI matrix switchers, maybe one with multiple inputs and outputs. Or it could be any other HDBase receiver that meets the same specs. Think of it as just one half of the required pair. It's designed to be integrated into a bigger system. And practically speaking, it's built pretty tough. Comes with mounting clips, a screw-on power adapter for reliability. It's meant for solid installation.
Got it. So it's like a building block for a larger HDBaseT setup. And speaking of installation, you mentioned power over cable, Pico-C earlier. How does that make the actual setup easier?
Ah, PayQ-C. It's a really nice convenience feature. It can definitely streamline installations. Basically, it lets you power only one end of the HDBaseT link, either the transmitter or the receiver, provided the device sending power supports POC. This means you don't always need a power outlet right at both ends of the cable run. For example, if you have a matrix switcher in your main equipment rack that provides POC, the receiver out by the display might not need its own power brick. It just simplifies cable management, makes things tidier, especially helpful in tricky spots where getting power is difficult.
Okay, we've covered a lot about HDBaseT's strengths, but there's a really interesting technical detail that lets it handle that cutting-edge 4K 60 Hz 4.4 signal within its existing limits. It's called color space conversion, or CSC. Could you maybe unpack that a bit?
Yeah.
What is it, and why is it so important here?
You've definitely hit on a key point there. It explains how some of these really high bandwidth 4K signals are managed over HDBaseT. See, the underlying HDBaseT technology itself, it currently has a data rate cap. It's around 10.2 gigabits per second. Now, that native bandwidth isn't quite enough to just pass the absolute latest uncompressed 4K UHD resolutions like 4K 60 Hz 4.4.4 directly, without any kind of optimization. And that's exactly where CSC comes into play.
Okay, so how does CSC work its magic? How does it squeeze the signal through without actually degrading the picture quality, which is what we're trying to avoid?
Right. So CSC essentially, it translates the color information into a slightly more bandwidth-efficient format just for the transmission part. But here's the really crucial part. It does this while preserving the native resolution, the frame rate, and all the important detail in the image. You can maybe think of it like representing an artist's huge palette of colors using a slightly smaller but still incredibly rich and accurate set of colors. For most displays, the human eye just won't perceive a loss of quality. The key takeaway is you still get that full 4K 60 4.4.4 fidelity where it matters most, the sharpness, the motion. There's no data loss, no compression artifacts. It's just a smart conversion of the color data to fit down the HDBaseT pipe. And importantly, the native resolution, the frame rate, the color depth, they all stay constant from the source right through to the display.
That sounds like a pretty clever workaround, letting HDBaseT deliver that high-end 4K within its current spec. But
Yeah.
Are there any catches, any limitations to this CSC approach that people should know about, especially thinking about newer video standards?
Yes, there are. And it's an important detail, particularly if you're working with the very latest HDR content. These specific HDTV Supply HDBaseT CSC products, they do not support HDR10 Plus or Dolby Vision. And the reason is quite specific. Those advanced HDR formats, they transmit repeated metadata packets constantly throughout the entire video stream. It's dynamic information. And that constant stream of dynamic metadata just makes conversion using this CSC technology impossible, at least right now. So this raises a key question for you, right? Knowing this, how do you decide if CSC is the right fit for your needs? Especially if you absolutely must have that dynamic metadata from HDR10 Plus or Dolby Vision. It's definitely a trade-off to consider.
Okay, good to know. So you've got this powerful transmitter, you understand the tech, the CSC nuance. Now, the practical side, the rubber meets the road. How do you make sure your installation actually works flawlessly? It sounds like it starts with the right cables and doing the install properly. What are the key tips? And maybe more importantly, what should you definitely not do?
Yeah. Proper cabling and installation technique are absolutely critical for getting the best performance from HDBaseT. It's not forgiving of shortcuts. First off, always use good quality Cat6, Cat6A, or CT7 cable. Cat6 is often the sweet spot, good performance, reasonable cost, and it's vital, absolutely vital, to stick to the TIAI A568B wiring standard when you're terminating the cables, punching them down, or putting on connectors. Consistency is key for all 8 wires. Now, to protect against random video flashes or signal glitches caused by EMI electromagnetic interference, shielded Cat6 or Cat6A cable with metal RJ45 connectors is highly recommended. Also, just physically keep the cables away from things that generate strong EMI fields. Mobile phones, microwaves, even fluorescent lights, high voltage lines, they can all introduce noise.
Those sound like solid best practices. But are there any specific common mistakes people make, things that seem okay but really mess up HDBaseT? Any big warnings?
Yes, absolutely. There are 2 critical warnings highlighted in the source info that we really need to stress. These are common mistakes that can kill performance. First, do not use EZ45 connectors, those pass-through style connectors. Second, do not use patch panels for your main HDBaseT runs. Now, these might be okay for standard computer networking, but for HDBaseT's high bandwidth real-time signal, they introduce problems. EZ45 connectors, while they seem convenient, often mess with the precise wire twists and impedance needed for HDBaseT. That leads to data errors, flickering, instability. Similarly, patch panels add extra connection points, extra potential points of failure, and impedance mismatches that degrade the signal, especially over distance. For your main HDBaseT runs, you really want the cleanest, most direct cable path possible between the transmitter and the receiver. Stick to these rules and you'll get much better, more reliable results.
Wow, okay, that's incredibly specific and really useful advice. So HDBaseT is powerful, but it definitely demands careful work. Now, beyond just sending the signal, this transmitter is often part of a bigger system, like the WolfPack matrix switchers you mentioned. What kind of control options do those larger systems typically offer? Because control is often just as important as the signal itself in a complex AV setup.
Right, connecting it to the bigger picture. It's not just about extending the signal, is it? It's about having integrated command over the whole AV setup. And yeah, for the wider WolfPack ecosystem, the control options are pretty extensive. There are dedicated apps, for iOS and Android phones, tablets. There's comprehensive PC software for control, a web GUI you can access from any browser for setup and control, even physical buttons on the units themselves for quick local switching. And then for deeper integration, there's optional touchscreen control, plus a whole host of drivers for the big professional control systems, Control 4, URC, Alon, Crestron, RTI, even codes for consumer stuff like Harmony remotes. It really provides a full suite of control methods to match pretty much any installation, from simple to highly complex.
So let's wrap this up. What does this all mean for you, our listener, thinking about your next big AV project? We've seen how this WolfPack 4K 60 HDMI transmitter using HDBaseT really tackles that challenge of long-distance, high-quality video, no compression, effectively zero latency, and using that flexible standard Ethernet cable. It's a solid solution for a very common problem. It gives you reach and uncompromised quality. This kind of tech lets you deliver that pristine 4K 60 video, immersive audio over hundreds of feet. Perfect for those demanding installs, conference rooms, auditoriums, large homes, anywhere you need top-tier AV to go the distance. And it integrates into a larger control system. It really empowers you to design setups that might have seemed impossible or just way too expensive before.
Yeah, this deep dive really shows us something fundamental about modern AV infrastructure, doesn't it? The tech is always pushing the limits of what we thought was possible, often using frameworks we already have, like Ethernet cabling. But it also leaves us with a really interesting question to think about. As video standards keep evolving, think HDR10 plus Dolby Vision, which we know currently challenge HD-based CSE because of that dynamic metadata. How will future developments manage to balance that need for extreme distance transmission with absolute total fidelity to the original source signal, including those really advanced HDR formats? What innovations do you think are coming next? What will bridge that gap, giving us both the incredible distance and every single bit of data from the most advanced content? Something to ponder.